Hello students, we shall look at the experimental determination of dryness fraction of steam. So we have seen that steam, you have got wet steam, you have dry saturated steam and superheated steam. And in wet steam, basically it contains a combination of water as well as steam. So the wet steam, the dryness fraction varies from 0 to 1. 0 means it is a saturated water and 1 is dry saturated steam. So the dryness fraction of a sample of steam can be experimentally determined using throttling calorimeter or a combined separating and throttling calorimeter. The former is used in if the dryness fraction of the sample is fairly high. Throttling calorimeter is used when the dryness fraction is very high, like 95 and above. Sorry, 0.95 and above. If the moisture content of the sample is high, then the combined separating and throttling calorimeter is used. So first you should understand what is throttling, and then we'll look into this. See, when steam is made to flow adiabatically through a contracted area, its pressure falls and thereby the steam expands. There is no transfer of heat. Adiabatic means there is no transfer of heat and no shaft work is done. This process is called as throttling. So I'll repeat once again. When the steam is made to flow adiabatically through a contracted area, its pressure falls and thereby the steam expands. There is no heat transfer and no shaft work, and this process is known as throttling. So throttling is an irreversible steady flow adiabatic process during which no work is done. Here change in U is 0, Q is also 0. So in the as per the steady flow energy equation, H1 enthalpy 1 is equal to enthalpy 2. Means enthalpy before expansion is enthalpy after expansion because there is no heat transfer. Thus we see that throttling is a constant enthalpy process. Enthalpy of the steam does not change. The heat content does not change. So this throttling process is used for determining the dryness fraction of steam. So you can see in the sketch you can see this is the steam main, means this is a like a boiler or some vessel where you want to find out the dryness fraction of the steam. So what you are going to do, you are going to take a sample. So this is a pipe for sampling. This is a pipe for sampling. In this pipe first we have put one pressure gauge. We have put one pressure gauge here. Okay. Then there is a valve here to control the rate of flow. Then this entire thing you can see is all insulated. You can see this is all insulated. So this is adiabatic process. This is totally insulated. Okay. Now the steam is just, the sample is taken and it is expanded. You can see this vessel here, it is expanded. And when it is expanded, I am going to see the temperature. So you can see the thermometer here and you can see the manometer here. Okay. So you have got thermometer and manometer and it is expanded, right? So the figure is a schematic of a throttling calorimeter. It is just throttling. One more process is there, that is separating and throttling, but this is just throttling. So when the steam is most dry, like 0.95, 0.97 and all, this can be used directly. A sample of wet steam is drawn into the calorimeter through a sampling tube. The pressure of the sample as indicated in the pressure gauge mounted on the sampling tube is P1. So first we take the pressure P1. The sample is then expanded adiabatically through a throttle valve to a pressure P2 such that the throttle storm is superheated by at least 5 degrees. One important thing you have to note is when the three steam which is wet steam here, when it is expanded, then it becomes superheated steam, and the temperature should at least increase by some 5 degrees, so that in the superheated region you can see both the temperature line as well as the pressure line, and you can plot the point. Whereas in case of wet region, in the bell shaped curve, you cannot differentiate between the pressure and temperature. Only in the superheated region you are able to find out the temperature and pressure, and you can plot them. That is why it is very important that the after throttling, the wet steam should become superheated steam, and it should be superheated by at least 5 degrees centigrade. So whatever is the dry saturated steam temperature plus 5 degrees, that becomes superheated by 5 degrees. So here we have measured P1, that is the pressure, initial pressure. Then P2 is the pressure after throttling, and T2 is the temperature after throttling. So these three values we have got it. Now we shall see the diagram, enthalpy entropy diagram. This is known as HS diagram or enthalpy entropy diagram. So, so how you are going to fix now? You see the diagram here. So again, I'll show. This is the dryness, constant dryness fraction line. Okay, this line is the dry saturated steam line. This is a dry saturated steam line. Now, what we are doing? Mm, we know the pressure 1 initial, the sample what we have taken, we have taken the P1. This is the P1 line. This is the pressure. We don't know where is the, we do not know where is the point lying, because we cannot differentiate between the P1 and a T1 inside the bell curve. Then what I have done, we in the after the expansion, adiabatic expansion, mean it is the entire container and piping, everything is insulated, so it is adiabatic, there is no heat transfer. Okay, after the expansion, what we have done, we have found out pressure 2 as well as the temperature 2. State 2 after expansion, state 2 is after expansion, so we have found the P2, we have also found out the T2. Now how I plot, you see this. So this is the constant pressure line P2, this is the constant pressure line P2, and this is the constant temperature line T2. Okay, so where this pressure P2 and T2 are intersecting, this point is the point 2. Okay, this point, this is the point 2. I know the point 2. Point 1 is lying on the, point 1 is lying on this curve. Point 1 is lying on this curve. Okay, this is point 2, we have found out point 2, this is point 2. Point 1 is lying somewhere on the curve. So what I will do, this enthalpy, this line y-axis is the enthalpy, constant heat content. Okay, so what I will do, I will just draw a horizontal line from the point 2, this point, which will intersect the P1 line. This will intersect the P1 line, and this point will become point 1. This point will become point 1. Okay, so I found out the point 1, and from this point 1, these lines, this dotted line what you are seeing, this is the dryness fraction line. Okay, once again I will repeat, because this is important to understand as well as to solve the numericals. You need to know the how to plot it. So we have seen, we have seen that uh, mm, we have got three values. One is initial pressure P1, then we have got P2,